The new SAT does include some trigonometry. Typically, from what we've seen so far, there's only like one question per section of trig, one in the no calculator section, one or so in the calculator allowed section. So it's not like it's everywhere, but you do need to know some of the basic stuff, and that's what we're going to review in this set of videos. So trigonometry, generally speaking, is the study of the relationship between the lengths of the sides and the measures of the angles. So the lengths of the sides and the measure of the angles, typically of right triangles, though technically it can apply to any triangles. But really what we're going to be dealing with is right triangle trigonometry. And the main little acronym to remember to help you relate angles and sides is SOHCAHTOA. And you can see how it's written out here. For sine, you find the opposite over the hypotenuse. For adjacent, you do the, for the cosine, you do the adjacent over the hypotenuse. And for tangent, you do opposite over adjacent. So if we have this as theta, and I want the sine of theta, I want the opposite over the hypotenuse. So that's going to be 4 over 5. For cosine, I'm going to want the adjacent over the hypotenuse. That would be 3 over 5. And for tangent, I'm going to want opposite over adjacent. So that's 4 over 3. So that's how you relate your angles and your sides. And let's look at an example. In triangle ABC above, the cosine of x is 5/13. What is the tangent of y? So we know the cosine of x is 5 over 13. So that means the adjacent over the hypotenuse must be 5/13. Now we want the tan of y. To get the tan of y, we're going to need the opposite over the adjacent, but we don't know quite yet what this value is. But we've got a right triangle, so we can use Pythagorean theorem to see to find out what AC is, right? It's going to be a squared, 5 squared, plus, we'll call this z squared, call this z, equals 13 squared. And so we're going to get 25 plus z squared equals 169, z squared equals 144, square root both sides, we get z is 12. So this is going to end up being 12, and now we can get our answer, right? It's going to be the opposite 5 over the adjacent, which is 12. So 5/12 is our answer. In the figure above, AB is parallel to DE and BC is parallel to EF. If DE equals 3, EF equals 4, and CF equals 6, what is the sine of x? So let's plug in all of our information first. Let's put it in the information they gave us. We know AB and DE are parallel. We know EF and BC are parallel. Typically, you can show that in your picture by this little caret thing. DE is 3, EF is 4, CF, this piece is 6, and AD is 4. And we want to know what is the sine of this. So if you think about it, we want to find the sine of x. That's going to be the opposite over the hypotenuse. So I need this length BC, right? The sine of x is going to equal this opposite side BC over this hypotenuse AC. So how will I get those? Well, notice first things first. If this is 3 and this is 4, this is a right triangle. You can do Pythagorean theorem. When you do it, you would realize that this is 5. You might also recognize that this is a 3, 4, 5 triangle. Well, notice now that I know that this is 5, and this is 4, and this is 6, I can add these up, and I get AC is 15. Well, now, what about BC? Now, here's the little trick, and we're going to talk more about similar triangles later. But just to introduce it now, these triangles are similar. And we know they're similar because they say that these sides were parallel. And if these sides are parallel, that makes these angles equal because both of these parallel sides are basically cut by this transversal. They meet at this common line. And as we'll talk about when we talk about parallel lines, this forms equal angles. And similarly, these angles must be equal. And if this angle equals this angle, and this angle equals this angle, and of course the two right angles are equal, these triangles are similar. And if they're similar, their sides are in proportion. So in other words, this side was 5, this whole thing was 15. And if they're in proportion, you can set up a proportion that says 5 is to 15, right? This small side is to this big side, as 4, this side over here, is to the side that we're looking for. As 4 is to BC. And now I'll just call that X. I'll call that A, whatever. Okay. So now I just have to cross multiply and solve. I get 5a equals 60, so a is 12. So we know this is 12. So finally we get 12/15ths, which is the same thing as 4/5. Now, that's one way to do it with our similar triangles. You also can note that if these are similar triangles, that the sine of this angle, because they're both the same angle, the sine of this angle, make it green, should be the same as the sine of this angle. And notice the sine of this angle, opposite over adjacent, is 4/5. So we get the same thing that way. Either way, you got to know some more things about similar triangles. We're going to review this in a little bit. So if you don't quite get that, we will. And once we've reviewed similar triangles, return back to this. But again, you find the values of your sides. You use SOHCAHTOA to find your trig functions. And that's it.